So, who was here last night? Do you remember that talk about, I need to get it wrong, this dirty onion thing? You remember that? Yeah. I don't understand it, but I'm a guy. But anyway, well, one thing that I wanted to point out was that Michelle talked to me earlier today, and she got this book to give out. It's by Joe Weston, and he talks a lot about what she was trying to say last night. And
I'll take it.
I just wanted to offer this up as a gift to. All right, somebody think of a good way to do that?
Throw it. Just give it to me. Give it to me. Throw it in this I raised my hand first.
Fight So the first person to bring me a beer gets it.
It's open.
Yeah, she volunteered.
Hers was not open. I say you just.
No, we're just.
That really looks supposed to. What I missed? Don't drink it. You know that's it. Don't do it. Don't do it. Oh, Rufy. Slept him a Mickey. 49. Oh, that's my home goal. So there. That's not it. I just want to Oh yeah, that's true. Everyone was like the things they played in the mid-90s. I was about to make fun of Mist, and then I remembered that there were Mist fans in our Mist.
So no one in this area.
I played Sam's Club.
So what is the part of the brain?
Seriously, you could not go to Sam's and not see Mist.
Responsible for the flight reflex?
Limbic system!
What?
Limbic system!
I heard the right answer.
Amygdala!
Okay, you go.
I had it first!
Wait a minute. No. Okay, now you have to. He's just going to give us a little education.
Okay, so a couple different parts of the brain. You've got the left hemisphere and the right hemisphere, left and right. Combining them, there's the corpus callosum, which allows people to communicate across them. Some people that have seizures, they get the corpus callosum cut through the middle. There's also the thalamus in your brain, which sort of acts like a switchboard. It communicates to a whole bunch of other different things.
Where's the soul?
You're going to have to wait for that for another talk. And alcohol receptors all over the place. That's all I can remember about the brain right now.
Is anyone from Untitled Space here?
Yes! Way here, motherfucker!
Alright, well, they have t-shirts available, and you should go see that guy. This is the last of their first run of t-shirts. Oh my god. We started in about 5 minutes here. I may start with some, maybe some surprise guests. Let's see what happens.
If that's what you call yourself. Remotely exploiting file. That's really what you call it. Matt, why aren't you on there? I totally meant, I thought you'd just go. Oh, alright. Either or tomorrow? No. You can sign up for tomorrow. What's the problem? He's not on the list. Yeah, actually. Alright, he needs to be on the list. He needs to be on the list. Why is he not on the list? Just start you. Why would I say no? Okay, because I'm resurrecting Ettercap. You need to be on the list. Hey, remember Ethereum?
Yeah, so who still uses the WPS? I'm like scared to death of this. Thumb drive. Alright, okay. So, this is a cool one. You know how you plug your thumb drive in and then it sticks out, and then if you were to carry your laptop all around it and hit the wall and cracks it or something. This is a cool thing that I found. It's a little. Alright. No, sorry. But it's a little device that I found useful, so I thought someone would like it. Alright, so. Okay, so I need some noise.
Roll like a man!
Actually, I had some trouble with my
Touchdown, right?
You would have to actually be
You'll give me a yellow, I might give it to you.
I think I'm just going to start. Alright, so I think we're about to get started. Welcome to day 2 of the Shmoocon Firetalks. What? Some noise. loud when you got free stuff?
Yeah!
More free stuff. We just spread it out. Alright, so this is what Firetalks are. If you were here last night, I don't want to go through it again. Does anybody have a question on what Firetalks are? Okay, cool. Alright, these are our awesome sponsors. Milam Security Group is giving away this cool ass parrot helicopter thing. Right? And an iPod, excuse me, a mini iPad to go with it. So thank you, Milam. Then we have the combination of folks that put some money in for the second prize, which is a laptop, which interestingly enough doesn't seem to be working right now, so I think I'm going to let Georgia have a whack at it. Anyway, so that was brought to you by Leverage Consulting, Lars, and Dirty Seth. Thank you. And then lastly, a iPod Touch, or a mini iPad by Liquid Matrix Security Digest. Thank you. So also we are giving away some awesome gifts, and once again, the consortium of Leverage Consulting, Lars, and Dirty Sec, all these t-shirts, these gifts that I'm throwing out here, thanks. And also Bulb Security, who is doing some of the streaming and recording work here, as well as with Mr. Iron Geek over here. It takes a lot of time to put these things together, and these are the folks that have stepped up and really helped me out. I just want to give a big thank out to Jack Daniel. He helped out with sponsorship. He's also the timekeeper and with the coffee paper. Also associated with doing the coffee paper review was Jason Oliver. He's right up here. And Sarah Clark. She's also working for us. So she's probably waiting there, but she also helped out with the coffee papers, as well as she's blogging this hub and live tweeting it. And then I also wanted to thank Nathy, who also helped out with the coffee papers. He's a speaker wrangler and helping out with some of the volunteer dinner stuff. And then with the judging, so as you know, we have those 3 prizes. Dakahuna pulled in Mr. Nubix, Miss Rogue Clown, and Miss Soap Turtle to help judge that.
How come everybody gets their name but me? I'm not good enough?
Sorry.
Who are you?
Where are they?
Mrs. Smooth.
All right, they're not here. And I already mentioned Georgia and Adrian. Security, very important. We don't want people without badges here, so Jaden Security and Casey Dunham. This is the schedule for this evening. Lots of awesome talks. What I really like here is that there's a focus on really fixing up old tools. Like tools that haven't been addressed in probably about 5-6 years old, and these people stood up and updated them for the security community. But we're going to have Craig Heffner, John Sawyer, Eric Milam, Doug Burks, and Travis Goodspeed to manage things up. And without further ado, that's all I have. And I'll throw out some prizes while Craig gets us up.
Yeah, Heffner! That's just an old book.
We're not talking about computers in this conference, right?
Where's your beard?
I had a beard accident before I came here, and my lovely harem of men over there gave me shit for it all day. We saw those last night.
I want to have your babies. All of them.
All right, so as you know, last night I asked people for their boxing intro would be. So this is what Craig passed on to me. So this is the Sultan of SWAT, the King of Crash, the Colossus of Cloud. Ladies and gentlemen, please welcome Craig.
You can give out a prize, who never knows what that means. Please, that's fine.
Babe Ruth.
Someone called out right voting.
I've heard like a bunch of people in this general.
Alright, so I'm Craig Heffner. I work as a security researcher for Tactical Network Solutions. And if you haven't already heard about the WPS vulnerability that was released last month, last month, I'm going to talk about it today. So if you're not familiar with Wi-Fi protected setup, it's really push-button security for people who don't know how to set up wireless security. Right? The idea is most end users just don't know how to do it. So the Wi-Fi Alliance said, okay, we're going to set up a protocol that makes it easy. And so pretty much any access point or wireless router you buy today has WPS support, and it's enabled by default. So basically it works, you push a button on the access point, you push a button on the client you want to connect to your wireless network, and they set up a secure connection, exchange some information, and now the client has all the information he needs to connect to your access point, including the WPA key. But there's a little bit more to the protocol than that. All right, so that piece we talked about, we kind of talked about the client and the access point. Most people kind of know about that piece. There's kind of this third party that's a little bit hidden, and that's the registrar. So the registrar actually is the entity that handles the WPS transactions with the client, and usually that's the access point. The access point has a registrar inside it, so they're one and the same. But the protocol specifies that an access point has to support external registrars too. So a registrar is, like I said, the one that handles all the WPS transactions. So in order to do that, the registrar has to know what the WPA key is, what the SSID is, so that he can authenticate clients and then give them the right settings. Alternatively, registrars can reconfigure wireless settings on access points. So let's say we want to become a registrar. Well, in order to become a registrar, you have to know the access point's PIN number. So this is obviously for security. You don't want just anyone coming along and becoming a registrar on your network. It can be done over 802.11, so it can be done wirelessly, and there's no user interaction required. Unlike adding a client where you have to push a button, there's no user interaction to add a registrar. So, if you want to, say, guess WPS pins in order to become a registrar, well, they're 8 digits long. The last digit's a checksum, so you really only have to brute force 7 digits. But that's still 10 million possible pins, and the WPS protocol actually is, for the most part, really well implemented. They took a lot of time to work out the protocol and prevent a lot of different types of attacks, including offline brute force attacks. So you really only have the option of doing an active attack. However, if you look at the spec, there's a section that talks about splitting passwords. And that's probably bad. So basically, the WPS is landman for wireless. They take the pin, they cut it in half, and they authenticate each half individually. So instead of having to brute force a 7-digit pin, you brute force one 4-digit pin and one 3-digit pin, which leaves you with 11,000 possible combinations. And practically, you can only really do 1 pin attempt per second because a lot of access points don't really have a lot of processing power, but still that only takes 3 hours. So in 3 hours, you get the access point's pin, and then the access point will give you the WPA key. It's fun. So it actually gets a little worse when you start looking at actual implementation flaws. So the protocol itself is obviously not securely implemented, right? But that's the protocol spec. Some ISPs, who will go unnamed, there's a nice big one in Switzerland, actually set the same pin for all of the routers that they give to all of their customers. So you just say, hey, this is the pin, and now you get everybody's WPA key. So I wrote Reaver, which, much like a honey badger, just doesn't give a fuck about your wireless security. I was watching that video last night, so I had to add that in the slides. Basically, it's going to run through all the possible pin combinations, starting with those very popular pins, obviously. And then it's just going to walk through every one, and basically it's going to go through and it's going to say, hey, is this first half of the pin right? And the router will say, no, it's not. Okay. Well, is this one right? No. Is this one right? Yes. Oh, good. We got the first half. And then it goes on to working on the second half. Hey, is the second half of the pin right? No. Is the second half of the pin right? Yes. Oh, well, now we have the first half of the pin, and the second half of the pin, and then we say, okay, give us your settings. And it'll print out the pre-shared key for, or rather the key for the network, as well as the SSID. And it typically takes, it depends on the access point, but it takes anywhere from 3 to 10 hours to do this. And it is an active attack, but you can pause it and come back and resume. And 3 to 10 hours for a WPA key, to put that in perspective, is really good. So, if you're an end user, you can disable WPS if A, your router even gives you that option, or B, your router actually disables WPS when you tell it to. Linksys is actually notorious for this. All the Linksys routers I've looked at don't actually disable WPS when you tell it to. Yeah. So vendor mitigations, really the only thing vendors can do right now is to lock WPS after some reasonable number of pin attempts, right? So after 10 pin attempts, just stop accepting pins. Some actually do this already, Netgear in particular, although some of them only block you for like a minute and then let you try again, and some of them block you out indefinitely. So if they block you out for a minute, it's really not that big a deal. It slows you down, but it'll take maybe a day or two. So if you want Reaver, it's open source. You can go to our website at technetsoul.com/products. There's a link to the open source code. The original advisory, so this, I wasn't apparently the only one looking at this. The original advisory is actually put out by Stefan Bebop, who was working on it independently for me, so we both kind of found it at the same time. You can go to his website for the original vulnerability that he published. And if you really like reading specifications and paying $100 for a specification, you can go to the Wi-Fi license site and get that too. We also actually have, if you want to support my children, and make sure they can eat, we have a pro version of Reaver, which is a nice little embedded box you just connect to. It's got a little web interface on it, and that's on our site also. So really, that's WPS. The attack is not that complicated, and it works quite well. I had several people come up to the conference and like, oh yeah, I broke into my neighbor's Wi-Fi. It's awesome. Like, don't tell the cops that. So yeah, question?
Well, yeah, I was wondering on the vendors that do lockouts, is that by MAC address after a certain number of incorrect attempts, or do you just sweep back and start again?
So actually, it's interesting. None of the ones that I've seen lock out by MAC. It's like a global lock. I did actually get one person who reported to me today that he found some, he didn't actually tell me what device it was, which is less than helpful, but he did say that his device only locks out by MAC, so if he changes his MAC, then he gets the game with the attack. But for all the ones I've looked at, and I would assume the majority, it's a global lock. They just don't accept any pins from my phone.
Will that authenticate clients that are already on? Or
No. I mean, it's not going to kick clients off that are already on. I mean, WPS is like a one-time thing, right? You use it just to get your client the WPA key, so you don't have to remember it and put it in manually. And then once they have the WPA key, you don't have to do WPS again. So it's typically not going to lock anyone out. Yeah, run VMware.
What about third-party operating systems like UDWRT or Tomato on
So DDWRT, Tomato, and OpenWrt do not support WPS.
All right.
So there is a version of DDWrt that runs on the Buffalo that they specifically made for Buffalo routers, and they do support a version of WPS. I have not tested that, so I don't know. But if you just like grab the open source stuff from the website, it doesn't have WPS support. Yeah, the Airport Extremes don't. They have like their own setup thing. They don't support WPS. MiFis do support WPS. That's all I'll say about that. So most people use the push button mode. But again, we're not really attacking the push button mode. We're attacking like the registrar feature. So it doesn't really matter if you even use WPS. So you can set up a WPA key manually, but as long as WPS is still enabled, it'll just give us whatever WPA key you set on the access point. Oh yeah, there are some that will, so some are a little tricky. Some will say WPS is disabled and it's not really. Some will say that they block WPS, but they don't actually lock it. Some will say they lock WPS, they'll act like they don't lock it, but they'll always respond saying you got the wrong pin, even if you got the right pin. So there are definitely some weird implementation things in there that you have to take into account. There's a bunch of like crazy options in Reaver, like the options list is forever long, and that's because I ran into all these weird things. You just have to play around with the options and find which one works. Which we have a nice database if you pay for the pro version. This support feature. You know what? My kids are hungry. They eat so much. It's like every other day. Eat. And any other questions? Nothing? All right, well, I will be, if you do have any questions, I'll be at the TNS booth all of tomorrow, second half day tomorrow, whatever. But I'll be there, feel free to stop by. We've got live Reaver demos running. It's great fun. Thanks a lot. Who really wants a t-shirt?
Drag after for coat.
Yeah.
Is Johnny Bravo over here? You're next. No, this is Todd.
That's great.
Let's go. Reboot.
Wrong word.
1024 by 768 is a beautiful flag.
Oh, I thought you were giving me a prize.
No.
Hey, what do you need? Which one do you need?
You might just want to try lowering the resolution. Do that? It just didn't. It didn't take? Okay.
Well, yeah, he needed that. I got one. I gave him, and actually, is that the Apple one? I already had one of those inside.
Another one over here. Oh God!
Oh my eye!
Someone find a lawyer.
Because it's outputting because I can see it. That's good. Yeah, that was good, man. It's on to. It's outputting, it's just not quite resolution.
What?
Isn't Apple user friendly?
It's using a Microsoft product.
What kind of hacker is this John Sawyer? You can't even make the
Hey
projector work.
John, do you have the split screen set up?
Yeah.
With PowerPoint,
Yeah, it's split screen.
you have a PowerPoint, you can select which screen to put it on.
It's up here. Yeah, no, it's going to the other screen.
Yeah, it's in the preference.
Waiting for your presentation stuff. Yeah, I don't know why you'd ever use an office program.
Okay, man. Oh, I fix this. Maybe I can see things here, but we have the cool glow-in-the-dark stickers. Yeah. These do not go far, so if you want it, you have to run up to the front of the See, this one, no, not the, you have to give it up.
I think you should just flip your slide this way.
Sorry, just had a few technical issues there. Very odd, but for some reason it doesn't work in the presentation.
I'm not sure how to make it send out resolution.
So, this is John Sawyer, and his intro is the package of the CCF team first. Team learning pen testing days. The Pwnage. Everybody welcome John Sawyer.
It just barely.
So, yeah, he mentioned, Team Last Place. I used to do a lot of hacking looking work for, Alice over there with Team Last Place and doing CTF. And part of what I've been thinking about recently is dual passive OS fingerprinting and application fingerprinting and network service, network client fingerprinting all through IDS. Kind of thinking about it in a different way. Losing my mic. So, now how many of you saw that P0F was re-released new version 3 just a few weeks ago? That happened the same day that I submitted the abstract for this talk. Completely unrelated. I'll just like to take credit that Mikhail somehow saw that I was doing this type of thing with an IDS, and he said, hey, I need to release a new version because mine is 6 years old. And yes, I know it's back. We'll get there. We'll talk about it and some of the features and kind of how it differs from what I'm looking to do using traditional IDS in the Snore or the new Certicata IDS engine. Just a little background about me. Senior security analyst within Guardians. I do a little writing for Dark Reading. I've written a Metasploit module for working with Shodan search engine, and it seems like every time I come up with a new idea for writing a Metasploit module, it's already been done. I have to think about how HD Moore made a comment when he was doing the expert research where he's like, I'm basically a vulnerability archaeologist. I find these bugs and I think it's really cool, and then I find out someone did it 4 years ago. And that was when he was talking about VxWorks and how he noticed that when he was scanning the internet looking for the UDP, he went back and looked at DShield data and saw that someone did the same exact thing in 2006. So that's how I feel. I start writing some of these things, I spend a day or two on them, and then see that somebody else did it too. So used to do CTF with Atlas and Cybertech and some of those guys, had a lot of fun. And I went to Mountain Bike, which people laugh when they know that I live in Florida, which is obviously not very mountainous area. But we have some cool trails. So, and some of them were kind of dangerous and make it bleed. Yes, Gainesville. And then I have some kids that are a lot of fun. For them that keep me very busy when I'm not in front of the computer. And I like to think I have a little aspiring hacker right there. He's wearing a...
Is that the one upstairs?
What's that?
Is that the ATM upstairs?
No. I haven't started bringing my kids to HackerCons yet because they're a little young, I think. So, but yeah, so there he was punching in ATM, and it ended up in maintenance mode. I have no idea what he was pressing. But he left really quick because I didn't know how to explain it. I mean, he was probably there for about 5 or 10 minutes, and so they would have known it. So what is passive fingerprinting? The opposite of active fingerprinting. When you think about fingerprinting hosts and stuff, most people are using Nmap to scan a host, figure out what their open banners and that type of stuff. Well, with passive fingerprinting, you want to have as little impact on the network as possible. You can do it from the network side, you can do it from something plugged into a span on a network switch, or you can do it via tap. We can also do sniffing on the client or server side. If you do pen testing, if you're sniffing on the actual system that you're testing from, you can find all kinds of interesting things in your logs as you go back and look at that later with IES or certain rules and stuff. When you look at the history of passive fingerprinting, it's traditionally been based around identifying operating systems. There's been a few things that have happened over the last 3 or 4 years where they've started looking at some other stuff, but really for the most part, when P0F came out, it was looking at certain signatures that would identify operating systems. That's changed with the recent release, and we'll talk about that in a little bit. So P0F then, it was written by Zalewski, the same guy that wrote Rat Proxy, Skipfish. He wrote a couple of books, Silence on the Wire and the Tangled Web. And then he's an avid photographer. So those are a couple of pictures from his website. So very interesting photography. If you have a chance, go take a look. But Mikal's a very, very smart, bright person, and put together a great tool. Unfortunately, it had not been developed in about 6 years. So, people were still using it, but it just wasn't well updated. There was no current fingerprints for modern day OSs or mobile devices. There were a couple of people out that had kind of put a few updated signatures, but there was really no coordinated effort behind that. It's really cool from the aspect that it do network address translation detection. So I used to work in a very large environment, a university environment, and one of the things that we would have a problem with was there was a NAC solution in place, and to get on the network you have to sign in. Well, there were these frat passes that became kind of problematic because they would put up these wireless routers that the first person that logs in, well, they would authenticate, but now you have 20 other people logging in, and now you couldn't identify which one of them was torrenting porn and copyrighted materials and things like that. So we actually would run P0F on the network, and it was really handy at detecting these NAC devices. So P0F, really great tool, but hadn't been developed until the day I submitted my abstract. So now, it still provides the same passive OS fingerprinting it did before. It still provides NAP detection. But one of the new beta features that was added is that it understands HTTP. So it starts fingerprinting HTTP requests and responses. It's really limited right now. There's only just a few signatures, I guess, in there, mostly for Apache 2X servers. It does have some kind of older, what he relates as exotic browsers that are being detected. But one of the things he said he wants to add is additional services like FTP, SFTP, SSH, and SSL. I definitely recommend taking a look. It is a cool tool. But we've got more stuff on the way. DHCP fingerprinting, this is something that has been researched over the last, I'd say about 2 years ago or so is when the first paper that I've seen had come out. And what they're doing is they're fingerprinting passively based on looking at the DHCP options that our clients are sending out. So, you know, machine comes on the wire, it sends out a DHCP request, it has certain DHCP option set, so you can create a relatively unique identifier for those. It's not super accurate, but there's a website out there called fingerbank.org. See, yes, I had to stress fingerbank because usually I say that people giggle because I said fingerbank. Yes, thank you. I appreciate that.
What's docking mean?
There's a couple of tools that are using the fingerbank DHCP fingerprinting database. Pwnage, Network Miner, and Satori. Prats is another passive OS fingerprinting tool out there. It has some of these features here. I think the limitation with this one right now is signatures. It's a cool tool. There's some nice features there, but there doesn't seem to be a lot of active development in providing signatures so that it has a lot of coverage for the devices that are protected. And then there's some commercial tools with passive capabilities. And these are really interesting because what I like about the commercial tools that are out there is they provide kind of more depth to what you can do with passive. They actually identify vulnerabilities. So there's nothing in the open source world that really does passive vulnerability detection. There's some cool commercial tools, yes, they do it. But no one's really kind of delved into that area passively in the open source world. So I'm blaming Josh Wright for this project. Josh Wright is an awesome guy. I used to work with him at InGuardians before he left to go write a wireless security course. And he sent out an email beginning of December that said, we need an extreme makeover for passive fingerprinting. There's problems where companies can't keep up with their growing environment. There's all these mobile devices that are being introduced. We have companies that are adopting multi-platform, everything from Mac to Linux and their traditional Windows systems. P0F hasn't been updated in 6 years until now. And there's these cool commercial tools out there, but there's nothing in the open source world. So I talked to Josh for a bit. I talked to DigiNinja's around here somewhere. I talked to him a little bit. And trying to decide what's kind of the best approach. And for me, I spent a lot of time in the defense world doing IDS, incident response. And so for me, it just kind of made sense. Why rewrite a tool? Why not leverage the capabilities that Snort and the new Cercada IDS engine have? I mean, they're already designed to tear apart packets and designed for you to write signatures for them. And the signatures are really easy. I mean, well, they can get complex, but for the most part, a lot of people understand Snort signatures. They know how to write Snort signatures. So it just kind of seemed to make sense to build something around using a common language and leverage that community. So what I'm putting together is a collection of signatures that I'm starting with mobile devices and mobile applications just because this is some of the research I'm already doing now. I'm working with my buddy Kevin Johnson and some other guys on basically mobile device security and looking at mobile apps, the insecurities. And so where it's going to start first is identifying mobile apps from a passive standpoint and then identifying actual vulnerable versions. So if you have mobile devices connecting to your network, let's say, we'll get to the offensive side of it in a bit, but there's going to be there's a major focus on mobile devices and applications in the first part, but then we're going to dig into more of the traditional vulnerable services and applications, web servers, web clients, all those. and then operating systems. And there's quite, the great thing about this is there's already a good community built around open source signatures. The Emerging Threats Project is an awesome group, and there are already numerous signatures in there for passive identification of some different vulnerabilities, mobile devices, and things like that. So we've got a good working base already with additional things that we're writing. Use cases. From the offensive and defensive side, there's a couple different things that you can do. From defensive, obviously, identifying apps, devices, vulnerabilities on your network. That's a huge deal. And if you don't have a lot of control over your environment, this makes a huge difference in being able to pinpoint those things, identify the assets, identify new things that pop up onto your network. But the other thing is, if you want to use it from a offensive perspective, you can use it to, wireless is really easy to do passive detection, passive fingerprinting. Have you ever been on a pen test and actually gained access to the network infrastructure, to where you could actually turn on a span? Yeah, that's a pretty handy point. You can do that. I've been in a situation where the IBS was open also, so there wasn't very much segregation. So getting into one of these network admins box, you actually had access to the IBS, and you can add a few more things onto the box and start sniffing the packet captures and process it through SNOR with this rule set. Vulnerability research. Again, there's a big focus on mobile app security, mobile device security. So, running this through a proxy or gateway and pulling all the packets and then parsing it through, you have that ability to kind of dig in and find some of those things that you didn't know were leaking data. Something that's sending out information via HTTP basic. And then, looking at distribution of this. It's going to be open source. You can, if you're already using SNOR or certified in your environment, you can use it as an additional rule source if you want, or you can run it side by side. It's no problem running multiple instances of SNOR on a box. When we were in the university to deal with the 10 gig links, we would leverage multiple instances of SNOR with different subnets that were broken up to actually increase performance. And then we want to contribute back to the Emerging Threats project. I've got a buddy that's working with me right now who is already one of the top contributors to ET, and he also has access to a very, very large network that we're able to pull a lot of sources of data from and actually create these blueprints. So. And then that's about it, Subtle hit. So, thank you. If you have any questions, feel free to come up to me. I'm out of time, and that's it. I want to thank all of you. Whoever's loudest gets shot.
Sorry, I had to.
Kind of over it.
Decapitation.
It takes some time.
Red. That is like an extra large. Alright, another measure.
He needs a left hook.
Nice, don't hook. You're on. I don't think you should be shooting 10.
For those that don't know, this is the man that resurrected Ettercap. Alright, so next up we're going to be having Johnny Bravo. This is the jester of Jerry Springer. The guy who will text you at 4 a.m. to talk about his feelings. I should have gave him that book, actually. The merchant of the man in the middle. Ladies and gentlemen, Johnny Bravo.
Mic check, 1, 2, 3. Alright. How you guys doing today? So just want to let you guys know I'm pretty nervous, so if I puke or pee myself, I apologize in advance. It'll make for great comedy. So.
And video, right?
And video, absolutely. So this talk is about the resurrection of Ettercap. Originally it was going to be called Resurrection. It's not just for Jesus anymore, but that got shut down. So we just went with Resurrecting Ettercap. And it's really more of a story of how a no-name douchebag like me just basically took over one of the most beloved projects in pen testing. And it's really going to go through just some of my communications with the lore and basically how we got to where we're at and where we're going to go. So, who am I? My name's Milam. I'm a senior security consultant for Activon Labs. On the Twitters, I'm Bravo Hacks, and IRC, I'm known as Johnny Bravo. As I was saying, the great rating Johnny Bravo, you can tell by looking at me, I'm definitely not the cartoon Johnny Bravo.
I don't know. I'm pretty close.
I'm pretty. So I just want to, a couple call outs first. Of course, Hackers for Charity.
Yeah!
Total inspiration to me in my career, in my life. Pure hate, Johannes Martin Boss sitting there. He's my brother from another mother. We do a bunch of pen tests together, and basically, I sleep, he does the work, and then I take the credit at the end. So, definitely want to call out Johnny Long, again, an inspiration, and He sent me an email this summer, which unknowingly gave me the confidence and to do something like this. So thank you, Johnny. I appreciate that. I was the guy running around fanboying out at the office that Johnny Long had just emailed me. So. And then Jason Street, he's my boy. He gave me the pep talk for this. He basically told me I was going to suck, but that was okay because everybody sucks and everybody's their hardest critic. So thank you very much. I appreciate it. I love that guy. So the topics we're going to cover: easy creds, Ettercap, the 073 versus the 2.6.39-4 kernel that came in and backtracked 5R1, communications with Allure Naga, the release of Ettercap 074 Lazarus, and the future of the tool. Some of the things we got planned that we want to do, and hopefully you guys can give us more ideas and get us going. So easy creds. Easy creds was just a simple bash script that I wrote that basically is really a wrapper for a lot of other man-in-the-middle tools I use during a pen test. It loads up Ettercap as pretty much its anchor or its core. It also leverages SSL strip, dsniff, URL snarf, has an option for sidejacking, which loads hamster and ferret, and then it also has other attacks, wireless attacks. It's got you can build a fake AP, it's got an evil twin AP, it's got the Hermetic split attack, as well as I added MDK3 to DOS people off the network so they can connect to your fake AP. So why did I write easy creds? Well, I got a text one morning or an IM from somebody I worked with who was in Germany at a large company, and they had just DOSed a giant segment of the LAN. And apparently he was a Windows guy, but he decided for whatever reason he was going to use Ettercap. Never used it before, didn't know how to set it up, didn't know what he was doing, and the attack pretty much started with man Ettercap. So I pretty much told him, that's really not the route to go. So I wrote, I went out on some forums. I found Lucifer had posted how to set up a fake AP, and I just kind of took that, I converted it into a bash script for him, and everything was kind of hard-coded. And then over the course of a year or so, it kind of became what it is now. So Ettercap, SSL strip, and the 2.6394 kernel. So Ettercap by itself, 073, no issues at all. It would run just fine, work, no errors. However, when you load up SSL strip with Ettercap in that kernel, for whatever reasons, it starts throwing the L3 errors, and I don't know if anybody's ever experienced that, but if you Google for L3 errors, it's just a lot of other people asking what they are, and not really a way to fix it. So I started dissecting kind of what was going on, and I noticed that when the IP tables were manually updated for the SSL strip portion is when the errors started to fly, which is odd because apparently it's an EPERM issue, but when you're in backtrack running, everything is root. So I still don't know why that was happening. I'm sure there's a lot of smart people out here could probably tell me, and I would appreciate it. That would be awesome. So easy creds was still successful, but now Ettercap was basically running out of resources within about 5 minutes and crashing. So I went to HackerCon and gave a talk on easy creds. I think it's automating man in the middle for winning. The talk led to an actual live discussion between me and Iron Geek at the time about the last official release of Ettercap. So I just said, what the hell? I'm just going to email Allure Naga and tell them I'm taking over the project. So, yeah, hubris, no. Stupidity, maybe. And most likely, yeah. Naive, definitely, right? But I didn't care. I did it anyway. So here's the actual email that I sent to them. You'll notice the subject line is, I've never talked to these people before. They have no idea, right? Request to officially take over Ettercap NG development. Basically, hey, we've done some things, can we take over the project? So I get an email back from Allure shortly after that. What were you doing? So we went ahead and we exchanged some emails. I showed him easy creds. One of the other guys who had fixed some issues, he'd sent him kind of his resume and stuff. And within a couple hours, we were project admins on the source code page. So, holy shit. This is fucking badass, right? I would never dream this would be happening, and you know what? I was like on cloud 9, and it was awesome. And then it was, holy Right? Because, I mean, it's Ettercap. Everybody knows it. Everybody loves it. It's a brand or a commodity that everybody that I talked to, even this weekend, has been like, oh my God, that's awesome, Ettercap, I love it. And everybody has a story about it. So, you know, why would I feel like that, right? Well, the doubt starts to creep in. You know, what if we can't do it? What if it's no good? You know, what if people hate it? And then the other thoughts that come along with growing up in a house where your daddy didn't love you enough. So, but seriously, I mean, it's one of those projects that you just can't get wrong. You just can't. So, when you look at it, here's my easy credit stats on the day that I sent out the email to Laura. You know, this is a project that I wrote really for myself and never expected anybody else to use. As you can see, on October 24th, there was 466 downloads, and I was like super proud of that. You know, it's awesome. Yeah, here's the stats for Ettercap on that same day. 762,496 downloads. Not to mention all the repos that it exists in and all the distros that it's on, right? So what's that? 762,000 downloads more than Easy Credits? Even Jesus was worried about it. Right? Like when the Son of God doesn't have your back, you should be a little bit concerned as well. But you know what, we did. And on December 4th of 2011, 074 Lazarus was released with the full support of the Lord Naga. They wrote a really nice passage of the church. And you know, we got t-shirts made, so we know that it's an actual official project. It's not a business project
So not official until you have a Facebook page.
That's not gonna happen. So 074 Lazarus, what it really was is it was largely bug fixes and code cleanup. This was really at the request of the Lord Naga. We came in and we're like, we want to do all this stuff. And, you know, what do you think? And basically he said, hey, why don't you slow down? Let's just fix what's there first. And then we can think about what we want to do after that. We can start putting stuff together, you know. You guys can do whatever you want. And, you know, I asked him, you know, how much do you want to be involved? And he said, it's your baby now. You know, we're passing it over to you. You go ahead and go for it. So one of the things that he did say was it's got to compile in Lion, which if anybody actually pulled the first push of, if anybody pulled the first push of the file, I pushed the wrong version, so it can compile. But I didn't tell anybody for about 2 hours. So. But the cool thing, you know, there was no more L3 errors, no more resource exhaustion. Like I said, we cleaned up a lot of the code. We just tried to make sure that it was as good as we can get it. There's definitely still some issues that we want to work through. There's, you know, a couple of bugs that come up, but for the most part, we got it out there. We got people talking about it again. And of course, I was on Google every day seeing who was talking about it, and I was really blown away at the excitement of people. So 075 assimilation, and that's the only thing I'm really part of the project for, is to give these things names. So Lazarus is my idea, and assimilation it actually comes from Piaget's basically taking the external world, internalizing it, and taking it over. Thanks. We've already coded these things that are here. We've got the NVNS spoofing, which is going to be new. I reached out to Moxie and said, hey, we're thinking about including an SSL strip functionality built into it. And, you know, he kind of, I don't know if he gave us his blessing, but he let us know it's okay. So multiple filter loading, IPv6 support, and other things that are definitely in the works, like a voice dissector of some kind. And, we'd like to really do an agent dropper that'll go out, and so you can poison other broadcasting. But we actually started talking about a major release, and I'm way more excited about this because we got some things that are cooking if we can really pull them off. You know, not just bug fixes. We really want to go to the next level. We don't just want to keep adding on to what's there. What we'd like to do is really Ettercap at its core is a router, and Ettercap becoming a tool for malicious routing, building a new kernel architecture, building an API, building an extension framework so that it has a core that runs that's self-aware, that can look at its resources, it can draw communications if it needs to, if it's getting overwhelmed.
Debugging API?
I'm sorry?
A debugging API, please?
Okay, yeah, so after all this we can talk, and I definitely want feedback from the community because we want to make this for you guys. So, but what we're doing is, the extension framework is basically, you can just write whatever modules you want and plug it right into Ettercap. So it's not this all-encompassed thing. You can basically, anybody can write whatever they need to for whatever network they're in, within Python or Perl or something, and just plug it right in, and it'll work with it. The current team, lead developer, Emilio Escobar, sick find, zero chaos if he ever pushes any code. Pure hate, who's just here for street cred. Thank you guys very much. Don't forget to give the hackers for charity.
Wait, I still have questions.
We can talk about that outside.
You didn't have one hair move during the entire time.
I believe that. I used to have hair like this guy, and then I shaved my head. That's why I got left. That's right. I get Woo! Anybody wants to hear about Jerry Springer, you can come out and talk to me about it. So it's called Grow Up Already, You Look Like a Freak. So it's quite a while since. All right, who wants a shirt?
Cool, I cheered earlier.
Roll with your first.
Nice. Thank you guys.
Just a reminder, we are filming Firetalks, and they're out on the thing. 5 to 10, please. Right. So, as you can see by the slide there,
That's cool. That's Burks. Yeah, I think it's the good job.
You gotta watch how he does this. He's had the same problem.
Hey, dude. I was waving at you earlier. You focused on Instagram.
Better.
Yeah, he's having the same problem. Oh no, he did it. He pulled it off. He has a better.
I bought a t-shirt.
Oh, actually, hey John, have you played with this?
A little bit, yeah. Johnny Robinson, nice and fun.
Nice and fun.
For anyone that's here, there's some pizza that we bought with volunteers, but if there's any left.
I noticed
Oh,
there.
It's back there. I guess it was
Only Robin Wood goes. Okay.
Alright. So the next talk is by Doug Burks. He's going to be talking about the security onion. After reading a lot about this tool, it's awesome.
Good stuff or bad stuff?
I actually had a question about it, and literally within like 2 minutes he got back to me.
It was a buy.
It was a buy. Okay, so ladies and gentlemen, he used to be a heavyweight at 230 pounds. Wow. You know, that Atkins diet. Now, just a light heavyweight at 175, hailing from Augusta, Georgia, home of the Masters, a master of network security monitoring. Doug Burks.
How's everybody doing tonight? Am I enjoying Shmoocon? Excellent, excellent. So, as he said, I am Doug Burks, and tonight I'm going to be talking about security onion. And so this is not related to last night's talk, security is like an onion. So this will not make you cry, although it may make you cry tears of joy because it saves you so much time and effort. So we'll see. So a little bit about me. I'm a Christian. I'm a husband and a father. I am a SANS GSE and community instructor. I work for a little company called Mandiant, and oh, by the way, we're hiring. We're a great company, so if you're interested, come talk to me later. Always hiring. Absolutely. You can find me on Twitter at Doug Burks, and if you feel like live tweeting tonight's presentation, you can use hashtag #SecurityOnion. Creative, I know. Okay, so I could talk about Security Onion for like hours on end, but I only have like 15 minutes, so in the immortal words of Jerry Reed from Smokey and the Bandit, we got a long way to go, but a short time to get there. So you folks got to listen quickly. I'm not going to sing that. Would you like to? There you go. Okay, so let's talk about establishing the needs. So how many people here are responsible for defending a network in some way, shape, or form? Good number of people. Okay, so how many people have a home network and you're just like interested in seeing what's going on your network? Maybe looking at the traffic on your cable modem or whatever. Okay, cool. How many people are just drunk and you're going to heckle me for not exploiting anything? Okay, we got. Well, just keep the heckling to a low roar, okay? Excellent, excellent. Okay, so feel the pain. So I know a lot of people said they were responsible for defending a network. So how many people have real true experience with IDS? Commercial or homegrown? So commercial? Okay, good number of folks. How many people rolled their own homegrown sensors? You built Snort or Suricata or something? Okay, so how long did it take you to roll that sensor? A week? A couple of days, maybe? Never really finished? Yeah, heard that story before, okay. So, one of the things that I'm going to show you in just a couple of minutes, earlier this week I did a test. I took my Security Onion, it's a free Linux distribution. I took the ISO, I booted it, I did the Ubuntu installation, I rebooted, ran through the setup wizard, and in a total of 8 minutes, had a fully functional intrusion detection system. Anybody ever done that with a commercial IDS, 8 minutes start to finish? Or homegrown, anybody? Okay. So let's talk about IDS. So there's a little bit more of pain with IDS because if you just have IDS alerts, do you have the entire picture? So you're looking at your IDS alerts, does that tell you everything that happened? Or is it just a snapshot in time and you don't know exactly what happened before the alert or after the alert? Right, so you see the alert and then you're going to have to go do some forensics or some investigation on the machine to figure out what's going on. So really what we're looking for with Security Onion is network security monitoring. So with NSM, we take IDS alerts and we add a whole bunch of other data to the mix. Right, so we have full packet capture, we have session data, think of like NetFlow type data. We have transaction data, so we have HTTP logs. Even if you don't have like a proxy server on your network that you can go look at those logs, your sensor is going to be building those HTTP logs and you can go reference those. So what does it take to actually get all of this NSM goodness? So if you were to build this by hand, this is kind of the diagram of the pieces that you have to put together. So has anybody ever tried to build Squeal and all of its components? Good number of people. How successful were you? Good successful. Did it take you a while?
I mean, I followed Richard Baitlick's directions. It worked great.
Yeah. How long did it take you?
About 3 hours, probably start.
Yeah. So a little bit more than 8 minutes, right? So we're going to do that in 8 minutes. So what's the answer? So Security Onion is a free Linux distro for NSM. As I said, it is based on Ubuntu. And it's very easy to use. I've got a setup script which asks you a couple of simple questions and you're off and running. The goal is that we can take just a Windows administrator who knows how to click next, finish, and he can instantly do NSM. Okay, so let's do a little demo here. So this is Security Onion. So for the purposes of time, with the magic of television and a little bit of virtualization, we've already done the installation, the Ubuntu installation. We're going to run through the setup with you. Let's hope that the demo goes well. Okay, so welcome to Security Onion Setup. We're going to say yes, we want to continue. We want to choose Quick Setup because we don't have a lot of time, right? So all we have to do is put in what we want our username to be. I'm going to be creative and use my name. What's your email address? And a password. Okay, so it's collected all the information it needs. It's now going to configure all of the individual services automatically. So we say yes, proceed with the changes. And this will take about 2 minutes. So I said before 8 minutes. You spend about 4 minutes doing the Ubuntu installation, you reboot, and this will take a couple of minutes to configure all the processes, set the database up, and get everything running. I'll go ahead and mention we do have Snorby, which I'll show you in just a second. Snorby, has anybody seen Snorby, played with it? A few people? So Snorby is pretty cool, it's sexy, it's Web 2.0, Ajax, Ruby on Rails, it's buzzword compliant. What does it do? So it's a web interface for your IDS alerts. Okay, so I'm actually going to show you 3 different interfaces, ways that you can look at the IDS alerts that you have coming out of the system. Okay, so we're done. Security Onion setup is now complete. So for those of you who have rolled your own sensors in the past, was this a little bit faster? A little bit? A little bit. Okay. So here we go. Let's go take a look at Snorby. So it does take a second to initialize.
Don't do it.
Don't do it, it's evil.
Don't permanently store it. Ah.
All right, so we use the credentials that we gave earlier. Notice the beautiful Web 2.0 Ajax buzzword compliant interface. It does have a nice dashboard. So we go to events. This is where we would see our IDS alerts. We currently don't see any because we don't have any traffic going, right? So I'm going to go down here and just run a little TCP replay. We're going to take a an old PCAP from the HoneyNet Scan of the Month project. This is from years ago, but it's a nice little PCAP. We're going to replay it to our ETH0 interface, where all of our processes are listening, so that's done. So now I'm going to go back to Snorby, click my Events tab. Now we see our IDS alerts, right? So for each of these, I can go and drill into them, and I can take a look at source IP, destination IP, all of the header information. I can view the rule that generated that alert to figure out, okay, why does it think that this traffic is suspicious? So one thing I'll say about Snorby, it's new, it's fresh, they're adding ideas to it all the time. But currently our implementation only has the IDS alerts. And I said before, that's a bit of a pain because that's not the complete picture, right? We want additional information to go along with those IDS alerts to aid us in our investigation. So let's go from Snorby to our next interface, which is Squirt. Squirt is another web-based interface. It's going to give us a little bit more information. So we're going to log in. Notice that it does kind of look, it's got a dashboard just like Snorby did, so it shows you some good information up front. One thing to notice here is that I said that Snorby only shows you IDS alerts, so it was only getting information from Snort. Right, but with Squirt, we're seeing other agents like SANCP, the connection profiler, so we're getting session data, PADS, the passive asset detection system, so we're doing some passive fingerprinting there, and OSEC, a host-based intrusion detection system. So all these services are automatically running, and they're all reporting back information that they're seeing on the network. We go across the top here and click signatures. We've got nice, pretty graphs to look at the alerts in aggregate. Click on the IP tab and see some nice pretty graphs that you can use for drilling into the data. If we had an internet connection, we could do geo-IP lookups for the source and destination IP addresses. And we go over to the query tab, we drop down and I want to do event detail and submit. And here we'll see our actual IDS alerts that we saw in Snorby before, but notice that we do see additional events like this PADS new asset. Right, so it's seeing new services running on your network, and down here somewhere we should have an OSEC alert. But so that does help aid us in our investigation. So that's the second interface that I want to show you now. Now that's giving you a little bit more information than Snorby did. Now I want to show you what's really the powerhouse for looking at your alerts, and that's the actual Squeal console. So we log in here. And we select all, we start Squeal. And the same thing, notice that we have our alerts here. One thing to notice is that Squeal does correlation. So for each of these individual GPL FTP site overflow alerts, instead of listing them individually, it's correlating them and increasing the count to 36. Right? So it's easier to look at these things in aggregate that way. The other thing that I'll show you, in addition to all of these agents that we have running in Squeal, the SANCP, the PADS, the HTTP prime for your HTTP transactions, Squeal has got access to full packet capture. This is huge, right? So if you're looking at an alert, say this FTP site exec, and I want to, so I can look at the rule that generated the alert, and I can show the packet data just like I could see it in Snorby or in Squirt. But let's say I wanted to see what happened before the alert or after the alert. Okay, so what I'm going to do is I'm going to go control-click on the alert ID. It's going to go to the full packet captures, pull out the entire conversation for that source and destination IP, and it's going to show me the ASCII transcript. So we can see here the attacker actually connects to our FTP server, attempts to, then he sends a site exec buffer overflow. We can see this happening, him sending a buffer overflow. Eventually we get down here a little bit further. Almost there. Here we see the attacker sends bin sh. Then he sends the ID command. We see that he is running his route. So now, do we know what happened here? Do we know if this is a successful compromise? Yes, we do. Absolutely. We know it's successful. So we can scroll down here, we can see the attacker looking through the box, seeing what's going on. And we can look all the way down at the bottom. You see him looking through directories and looking at the password file. So this is just in a couple of clicks, pivoting from an IDS alert and getting a huge amount of information about what happened before and after that IDS alert. Okay, so that's Squeal. So let me show you one other thing. So just as quickly as we can set up this first sensor, we can set up a second sensor. So let's say that we're here at Shmoocon and we're running Shmoocon Labs. So we want to set up a sensor here on this network, and then we've got another network on the other side of the building, so we've got to place another sensor there. So let's go run through the setup wizard on our second VM. And this time we'll use advanced setup instead of quick setup because we just want to choose a sensor. And we're going to point it at our server. We enter our username on the server. Keep the default of stored. Choose our interface. And we proceed. Setup has all the information it needs. It's going to automatically configure everything. It's going to connect over to the server, set everything up on the back end. And in just a few seconds, it'll be done. Same thing as before, it does all the configuration, it starts all the services for you. As soon as this is finished, we'll do the same thing. We'll replay a PCAP so we can see that this sensor is up and running and transmitting all of its alerts back to the central server. All right, that's done. So we go here, we replay our PCAP. That'll take a few seconds. And while that's running, we can go back over to our Squeal console. We go to Change Monitored Networks. Notice here that we have our Shmoo Master, which was our first sensor that we set up. Now we have Shmoo Slave. This is our second sensor. So we select all, start Squeal. And if we look at our sensor column, we have our original Shmoo Master alerts. Scroll down, we have our Shmoo Slave alerts. Right, so because we replayed the same PCAP, we see the exact same alerts on Shmoo Slave. Is that beeping for me? Okay. All right, so I'm going to very quickly wrap it up here. So I showed you the web interfaces, I showed you pivoting to full transcript, how quickly and easily you can set these things up. There's a ton of other useful features in Security Onion. So please play with it. If you want to see it in action tonight, you can actually go down to Shmoo Labs. They have it up and running. My friend Liam Randall, he set it up with this beefy server, and they're actually monitoring live data with Security Onion right now. So if you want to learn more, go to my website, securityonion.blogspot.com. Please, if you enjoyed this presentation, if you like Security Onion, please, please, please vote for Toolsmith Tool of the Year. You'll see the link at the very top of the page. And some other links to get you started with the project. One last thing, in honor of Steve Jobs, if anybody is interested, please come up. I have some Security Onion DVDs to give out for free. So thank you all very much. There he is, Scott's the man. Scott's at the All right, if you want a t-shirt, yell Security Onion as loud as you can. As loud as you can! Thank you, thank you. We got more, keep it coming.
And so, I've got a question. Does anyone here want to go to the party but doesn't have a wristband? Okay, does any of you have a t-shirt that you can trade for a wristband? Okay, that's okay. Come see us in the back of the room. You see, okay, got one, and now, yeah, so anybody who, women first, of course, any women in the room would like to go. But, okay, so we got 2 down, there's 3 left. Come see us in the back.
Party? You guys like partying? I don't know. I'll know after I eat. Yeah. Have you seen it yet? Oh, that's right. Yes. How much water did I drink? You're a party animal. You hide it. You're a party animal. Show us you're in the party. Show it.
Goodspeed. The good behind the good fit. The real man with the pink pager.
I know.
The one who puts packets in packets. Travis Goodspeed.
Alright, so show of hands who likes defending stuff. Get out. Who likes breaking stuff? Now usually when we break stuff, we're exploiting a bug, right? Here we're not exploiting a bug, but we're going to be breaking all sorts of shit. Who recognizes this diagram? Whoever thought this would be useful to understand? I'm really surprised. You knew more than I did. So, this is how we're all taught to do networking. We're taught that you have a layer 7, which is wrapped inside of layer 6, which is wrapped inside of layer 5, and then it goes all the way down to the bottom at layer 1. And we're taught to believe that each layer will properly deliver frames that came from the last one. And we believe this because every time we get a packet, the checksums make sure that there's no damage in it. And the only exceptions we see to this are when we intentionally turn checksumming off. But it turns out that checksumming is only intended to prevent against accidental error. And what I'm about to present today is a remote exploit for layer 1 that exploits the physical medium of a wireless network in order to inject a raw packet, a raw frame. There is no software bug in the stack that we can blame. There is no hardware bug in the receiver that we can blame. This exploit is standard compliant and portable to almost every wireless networking protocol that includes a variable length field and lacks cryptography. Not that any of us would know where to find any of those.
There's 6.
And as I go through these slides, I want you to think back to Atlas's talk on layer 1. And whatever pieces of that looked foreign to you, I want you to realize that foreignness of it, that lack of understanding of how layer 1 works, is just as much of a mistake and just as much of an absence as any misunderstanding about how layer 2 works. I think it was Bruce Potter who famously said, "For the love of God, learn how layer 2 works." Well, I'm saying now, for the love of God, learn how layer 1 works. Without further ado, here is a 5-layer exploit. Our situation is that Mallory wants to attack Bob, but Mallory has no radio. This is a radio exploit in which the attacker does not control the radio. All packets have to go through Alice. And Alice, for whatever reason, is filtering the exploit that Mallory wants to use. So if you've read Uninformed Volume 6, Article 2, when Johnny Cash, H.D. Moore, and Sniffing were presenting exploits for beacon frames and for probe responses, you can't really send a beacon frame or a probe response over the internet because they're unique to Wi-Fi. They don't fit within the IP space. But using packet-in-packet, you can. The other part is that this is for packet injection. So Mallory is going to send a specially crafted string anywhere within the packet as a whole. It can be in layer 7, it can be in any layer 7 protocol. I don't care which, so long as it's not encrypted and whatever obfuscation exists is reversible. What's going to happen is that by a radio error, this string will become a packet. Okay? So if you've ever done Wi-Fi injection and you had to load a special Wi-Fi driver in order to do this, I'm going to not only show you how to do it without a special driver, I'm going to show you how to do it in someone else's network. You can make a web page with JavaScript, and the JavaScript will cause Wi-Fi frames to be injected on the users of the web browser going to this page. And for Zigbee, it gets so simple that I can teach you the exploit here, and you can scribble it on a napkin before you leave. 4 zeros and an A7. Scribble that. This is the Shmoocon 2420. This is the Zigbee chip that we did the original exploit on. This is not a computer. There is nothing Turing complete in here. There is no program memory. There is no code. This is just a finite state machine and a bit of analog wizardry. All it does is load packets into a buffer. And we're going to exploit it, and not because of a hardware bug. So again, this is a remote 5-layer exploit. The string will become a packet, and the attacker does not have a radio. There were no USRPs used in this. There were no radios of any kind used in this except to verify the effect. The party playing the attacker only controls a string within a packet and does not have a radio. And almost all digital radios without cryptography and with variable frame lengths are vulnerable. This is what our exploit looks like on Zigbee, or IEEE 802.15.4. As you run through the packet, you have the preamble. This sets up the radio timing. Those are your 4 zeros. And then you have your sync field, which is your A7. That's your A7. Every packet begins with that at layer 1, but no packet sniffer will show that to you because the radio takes care of it. The radio lobs it off. The zeros aren't even interpreted as data, although I'll get back to that in a bit. And that italicized region, lower on, beginning with 0A, 01, 08, that is the packet that is injected. And you see before it, there are 4 zeros and an A7. That's all you need to do a Zigbee packet-to-packet injection. And it works. If you transmit that packet as a whole, the inner packet will fall through and be remotely injected. This is the OSI model exploited. I mean, every promise that an attacker can't jump from an inner field to an outer field has just been broken here. So please read the fucking paper. I did this work with Sergey Bradis, Ricky Melgares, Rebecca Shapiro, and Ryan Spears, and it just so happens that we're all here at Shmoocon. Team Appalachia. So let's get to how it works. This is a slide from, stolen from a lecture, but it was my own lecture, so that's okay. Michael Osmond and I did this in real land character pages. This slide depicts in marker what a packet looks like. It begins with a preamble, that's the zeros. Then there's the sync field, also called a starter frame delimiter. The preamble exists to set up the radio tuning so that it knows how fast each bit will be. And the sync field exists to mark the beginning of a packet. So that chip that I showed you, the microscope photo of a few slides back, the way that that receives is it just cycles all of the incoming bytes through a matching shift register. And when it sees 00A7, the end of that sequence, it snaps in, and then it looks at the very next byte, that's the length field. And that's how it knows how many bytes of data to load into the buffer. And when it finishes loading them, it raises a pin to tell the microcontroller, hey, we've got a packet waiting. Now, if there's any damage in the data section, we all know what happens, right? The CRC will be invalid. That's at the end. When that CRC is invalid, the packet gets explicitly dropped. And if it's explicitly dropped, well, we never see it, so the damage is something that we pretend doesn't happen. And it's something that we are told as layer 7 or layer 6, or even as layer 2 developers, to expect not to exist. There's another case, though, which is the case that I care about. If the sync field is damaged, the packet is not dropped. It won't count against your link quality statistics, because the radio never knew that a packet began. It thinks that it's still listening to background noise. Now, to someone who cares about performance, this is exactly the same as a dropped packet, right? Because the packet never arrived, maybe our statistics are a little bit off, but it's 1 in however many, so we don't care. But if it just so happens that an attacker puts another sync field inside of the data section, like 4 zeros and an A7, then the receiving radio latches at that point and thinks that the packet begins there, in attacker-controlled regions of the packet. So Mallory, when she crafts a packet like this, can take any old Zigbee packet, anything out of a packet sniffer, beginning with the length and ending with the valid checksum, and she can put 4 bytes of zeros and an A7 before it, and send that over the air, and about 1 time in 1,000, the sync field at the top, that first A7, will get damaged. And when that gets damaged, the inner packet and not the outer packet is returned. That is remote layer 1 frame injection. And you can do it if you know 4 zeros and an A7. Isn't that cool? And most importantly, it works. This highlighted region in the upper section, that's the inner packet, the upper section is our packet sniffer grabbing entire packets. On the inner section, we filter off the address so that the outer packet never shows up. And those 2 inner packets, those 2 that are highlighted in the lower section, those were remotely injected by our layer 1 exploit. And all this requires is that you control a long enough string inside of the packet itself. You need your packet length plus 5 bytes. Isn't that cool? So this is how it works in theory. In theory, you've got your OSI model, and you have individual packets, and you have these layers of separation, right? We're told to respect and appreciate these layers of separation when we're learning networking, and then when we're relearning it because we learned how poorly we learned it the first time, we start finding all of these cross-layer interactions, right? We learned about SQL injection, and about how a software bug inside of SQL injection, a software bug inside of PHP can allow our SQL statements to be injected. And we also learn about fail defenses, like simply doubling single quotes in SQL, right? And this fails when different character encodings are included or when extra escape characters exist. And in each one of these cases, though, it's a software vulnerability. There are 2 others that Sergey and I have been working on that are hardware vulnerabilities, which are, in fact, remotely exploitable. But this is even cooler because this is not an exploit of any particular implementation. I can't stand up here and say that you should buy Ember instead of ChipCon because ChipCon is vulnerable. Whether you should buy ChipCon instead of Ember because Ember is vulnerable. Because this is unique to the way that the physical radio layer works itself. I can't even say use Wi-Fi instead of Zigbee because this also works on Wi-Fi. Rate shifting makes it terribly difficult to implement on 11G and the faster parts of 11B. But when you get to low data rates, this trick works. You can remotely inject a Wi-Fi frame.
You can make an ISO image that, when downloaded, remotely injects beacon frames. Isn't that cool? So this is encapsulation in the textbook. This is how encapsulation works in the real world, in the presence of errors. Doesn't that little thing so cute? Because the OSI model teaches us to plug together different complex pieces, right? We have all of these layers, and they're each very complicated, and they each have strange side effects. And we're taught that it's okay to have these lower layers beneath us that we don't trust, so long as things get filtered along the way, because we can trust the boundaries of separation between these layers of abstraction. But then we wind up building things like this and not even recognize it. If this had worked, it would have shipped. It's true. Raise your hand if you've seen something this ugly in the field.
That's pretty.
Things be changing. So this brings me to Bradis's law, that layers of abstraction become boundaries of competence. So the whole time that we've been making fun of the network engineers that don't know what goes on beneath the hood, the Java programmers that don't know what a TCP sequence number is, even though they've been writing TCP servers for years. We're guilty of the same thing because we as a profession have not been looking in layer 1 until very recently. Sergey and I discovered this vulnerability along with the rest of our team in 2011. Sergey would know the exact date, but I believe it was mid-February. And it sat undiscovered between 1933 and then. There was exactly one piece of prior art, which I don't have time for in this lecture, but you will find if you read the fucking paper. It's called Packets and Packets, Orson Welles' in-band signaling attacks for modern radios.
That's awesome.
We managed to port this whole exploit, this whole method of breaking layer 1 for every form of unencrypted digital radio uses a trick that can be found in Orson Welles' 1938 War of the Worlds. And it's sat undiscovered until now.
Except by Orson Welles.
Except by Orson Welles. Son of a bitch beat me to my exploit by more than the invention of the computer. So that's how you break layer 1, and thank you kindly. And I'm happy to take questions in live time. And not to abuse a position of authority, but I really could use a wristband.
Here.
Thank you kindly.
Foreign.